Good morning, sir. We are just waiting for participants to add. Basically, there are only 13 participants. We are just waiting for 5 minutes.
Are you getting my voice?
Yes, sir. Your voice is coming.
Okay, just I check. Okay, stop video. ठीक है.
Good morning, sir. This is Dr. NKVV.
Good morning, Dr. Awasthi, I think.
Hello, sir.
Yeah, good morning.
Welcome, sir. Welcome.
Welcome. So, yesterday you have conducted your lectures, yesterday and day before yesterday?
Just pardon, sir.
Uh, Means today is the third day?
Yeah. Third day.
Yeah. So today, two lectures from IRS side. At
Yeah.
first, I will take
Yeah.
myself, Dr. Suresh Kumar,
Yeah.
and I will discuss on soil mapping part.
Correct, sir.
And at 11:50 45, our colleague Dr. N.R. Patel, who will be discussing on crop mapping and acreage estimation.
Sure,
And
sir.
tomorrow also he will be there in morning session. And
Sir.
then one fourth lecture is on microwave remote sensing in agriculture by our another faculty.
Yes.
And at the end, and on 12th, there will be one lectures on crop water requirement. Yeah,
Sure. Yeah.
this is the schedule.
Yeah. Yes.
So we have make a lot of email. And earlier I used to agree for the entire 5 days, but later on some of our in our office, because we used to conduct online lectures as a short courses in our institute also. So it was thought not appropriate to deliver entire lecture series.
Okay. Okay, sir. It's all right. आपने जितना अभी हमको दे पा रहे हैं कंट्रीब्यूट कर रहे हैं यही बहुत है हमारे लिए.
And but I assure you that in future, whatever any help you require from my side, or any, I will be always available with you.
Thank you, sir. Thank you. Thank you very
Yeah.
much.
I think in Java, earlier we used to get a BTech final year student for internship also from Jabalpur,
Yes.
Agriculture Engineering College.
Yes.
Uh, but the mainly problem with IRS is that we don't provide the hostel. That's why student also suffer a lot.
Yes. Yes.
Yeah.
Yeah.
So that's why students are not inclined, or also because for a short period of time it becomes very costly to get accommodation outside.
Yes. Yes.
Yeah. But certainly, if you anywhere in your course program or in research programs, if actually IRS have the some summer internship program, in that student can come, but always the same thing is that hostel is not available. Because we have very limited accommodation facility, which is for meant for our IRS education program.
Yeah.
Yeah.
Uh, so for 22 is there. Should we start, sir?
As you like, I can start, or you want 2 3 minutes more to wait, then you can do that one. No problem from my side.
Okay. Okay, just wait for the 2 minutes only. So that otherwise the next schedule will be disturbed. Now. That's why I'm just
Yeah,
worried.
yeah, yeah. 2 3 minutes we will more
Yes.
wait. Then I will start. How many total participants are there?
Uh, Yesterday 66 were there.
Okay, okay, 66.
But but the registration is 180 plus actually.
So why? Because that time is not early or late. It is appropriate time for joining that one, and anybody can join their mobile itself. Nothing required to go into a classroom.
We can say that persons are interested in a particular lectures.
Okay, okay. But sometimes particular lectures and other lectures also equally.
Yes, yes, interrelated also.
Yeah.
ओके 2 मिनट एक मिनट बच तो आप उसको स्टार्ट करना थोड़ा उनका परिचय देके सर आपकी साइड का वॉल्यूम क्लोज कर दो
Good morning, everyone. This is Dr. Saurabh Nema. We welcome you in the third day of lecture series on spatial data use in agriculture. We have, am I audible? Hello?
Yes,
Hello?
audible.
Am I audible, sir?
I am getting your voice.
Yes, sir, you are audible, sir. Carry on, sir.
Good morning, everyone. We welcome you all in the third day of lecture series of spatial data use in agriculture. We have Dr. Suresh Kumar sir with us, who is giving lecture today in soil mapping and land use planning. So we welcome you, sir, for giving us time, and we're requesting you, sir, to please start the session.
Okay, thank you, Dr. Avasti. Indeed, it's my pleasure to be delivering a lecture on that, and thereafter my colleague will deliver the lectures. And just I brief you that I am here in Indian Institute of Remote Sensing since 1993, and I joined here after doing my PhD from PhD in soil science from GV Pant University of Agriculture and Technology, Pantnagar. Actually, I did my graduation, PG, and PhD, all 3 degree program from Pantnagar University. And since then, I am here at Indian Institute of Remote Sensing, and I am working on applications of remote sensing, GIS, in field of soil resource management. And in this, you can say that is a since very beginning, my specialization in watershed management, soil quality, land use planning, soil erosion modeling, soil carbon stock assessment, national level, and so various projects I did. And today I will be interacting with you all with the lecture on soil resource mapping. Are you getting my slides now?
Yes, sir. It's visible.
Okay. So in this lectures, I will be covering on soil resource mapping, how to do soil mapping, and some parts on how to assess the potential of the land for land use planning, and at the end, some mapping of the degraded lands. If we see that is the when we talk about the geospatial technology, then it is we say it is the integration of remote sensing, GIS, and GPS. So in soil resource mapping, what is the status present is there and why we need to map soils, that I will discuss, and some examples with the degraded lands mapping. And at the end, today we are more focusing on digital soil mapping. So what is its scope and potentials can be also will be discussed. As we say, that is the remote sensing provides you a reliable update information of crop, soil, terrain, and geology. That's why today several remote sensing data are available. Some data are freely available. So, for example, Landsat data, Sentinel data, and at higher resolutions, ranging Landsat from 30 meters and Sentinel with 20-meter resolutions, which is making use for natural resource mapping. GIS, we know that is that there are various GIS softwares are available, which are open source GIS softwares. For example, QGIS, which are available, and Elvis GIS softwares. Today you can say the remote sensing satellite data or GIS softwares are not costly affairs. They are freely available to download and work and proceed in our project or research work in that one. And GPS, everybody is familiar with that. You are having various resolutions. GPS satellites are available to get the geographic locations. If we see the remote sensing, as you are aware that remote sensing is a technology where the radiation coming from the sun interact with your earth objects and get reflected back to the atmosphere, and the reflected radiations, basically it is reflection is based on the how much radiations get interacted with the various objects, and thereon you are getting the reflectance value. So reflectance behavior or reflectance pattern or the absorbance in the distinct spectral bands are studied or used to characterize the feature of Earth surface or Earth objects. So basically, remote sensing, we summarize that it is an interaction of electromagnetic radiation or energy to the object and the reflected or emitted radiation, and that is used for the we use for interpretation of various and characterization of the object. So become as our theme is to how we can use remote sensing data for soil mapping and why we need soil mapping. Basically, sometimes questions comes in our mind that when soil maps are available, then why we need to map soils every time. Actually, I will tell you that is a soil mapping learning concept using remote sensing data is very vital for doing any project or any research work, because as you know that is the National Bureau of Soil Survey and Land Use Planning. They have prepared the soil map of the entire country at 250,000 scales. They have surveyed and prepared the map at 1 is to 500,000 scale. And besides, so soil map at a very coarse resolution, you can say at a small scale is available, and it doesn't serve the purpose of your district level planning or block level planning. So this data is only useful for state level planning and country level planning. And the purpose was that it was prepared in 1970, surveyed in 1970 80s, and today these maps are available. So you can say these maps the characterized in the year of 19 late 70s or 80s, so they are already 40 years old. Maps are there. If characteristics, it's the physical chemical characteristics change over the period of time. So this data, how much valid for your, if you are doing for soil quality or you are going for soil fertility, then this data may not be useful for you. Soil Land Use Survey, another organization which is located in New Delhi, and it gives the basin area. Some soil maps at 50,000 scales are prepared, but not continuously for the entire country. State Soil Survey Department also collect the soil samples and analyze its basic soil properties, and every states have. And for Madhya Pradesh, I can say that is the Madhya Pradesh Remote Sensing Application Centers are having soil map at 1 is to 50,000 scales prepared, I think 10-15 years back. NRSC also have prepared 1 is to 50,000 scales maps. So you can say the maps are available, but not at your desired scale. That's why, as you know, the soils are is a dynamic, and its properties changes with the management. So the how much old survey has been conducted, it depends on your requirement. If your requirement is you have to see the requirement, which map you require or which informations you are looking for. To know current status of soil properties, you have to do the soil mapping. Then problem comes where that it comes, that is where we take soil samples. It is very difficult questions, because suppose you are moving in one district, and on the road, and you can collect anywhere, but where to take the soil samples, what the criteria should be there for taking soil sample or to decide soil sampling. This is very important. So I am going to discuss in this lecture, that is how remote sensing can help you for identifying the location area where to take the samples, and how these samples, if you take the soil samples and analyze those soil characteristics, it will represent for how much, how is much area, or how much soil landscape extent area it will be applicable. So this information, this idea, or this can be achieved using remote sensing data. And sometimes what depth we need to take the soil samples. So you suppose you are doing for soil quality, you are working for soil health, soil fertility, soil carbon stock, then in general we require the soil mapping of 0 to 20 centimeter depth surface, and 20 to 50 centimeter depth of the surface. But if you are going for a genesis study, how these soils are formed, or when it is the soil survey people used to do, soil surveyors or soil maps, when we prepare, at that time we need to study the soil profile. And you know, the soil profile means minimum 1.5 meter depth, or that or to the soils, before if you interact with the stone or rock, means parent material. So up to parent material we used to see. So soil profile study is very difficult task. That's why soil mapping, standard soil map preparation is very difficult, and that's why it is not updated very regularly. But if you are doing for soil fertility, soil health, soil carbon, soil quality, like this, for your watershed management program, then you need not to study the soil profiles, you need to the surface and subsurface soils. But the questions comes, I can take the samples, but where to take the samples, what should be the
Sir,
criteria, how remote sensing data can help, that part I can discuss with you.
sir, your presentation is not visible.
Yeah.
Your screen
What?
is not visible, sir.
Not visible?
Screen sharing, sir.
I have shared my screen.
But
अभी दो slides
Screen is not coming
yes, sir.
now.
It's still not visible, sir. Sir, ये last two slides it's a problem. Earlier it was coming.
Okay. Is it coming?
Now it's okay, sir.
Okay. So remote sensing data need to be interpreted we need to identify soil landscape units, known as a soil physiographic units. So we need to collect the soil samples based on soil landscape unit. How we can generate it? How we can find out the soil landscape unit? Uh, we see that in the soil, if we take the remote sensing data, the reflectance characteristics, we can see that in various wavelength their soils reflectance varies. And you know that is the if soils are low in organic carbon give high reflectance, and if you are high in organic carbon it will give the low reflectance. But the reflectance characteristics we are getting of the surface soils, and where we are looking for the subsurface soils characteristics, because surface, very thin surface interact with the radiations and give the reflectance. And for the soil study we are not interested in only the surface, we are interested in subsurface. That's why direct surface interpretation of remote sensing data is not useful for soil mapping. We go for mapping, we are interested for the subsurface objects. So remote sensing data are used. Direct interpretation of soil is not possible for mapping the soils. We go for indirect interpretation of remote sensing data. How we do that one, we see. Then it comes that is when to take the remote sensing data, because the remote sensing data give you a very synoptic coverage of the landscape. And you get the temporal data, rabi season and kharif season. Generally we take the satellite data when there is no vegetation cover. There should be means when the area is fallow, or in when crop is harvested and there is no vegetations or minimum vegetations are there, at that time we take the satellite data. And or standard false color composite pre and post monsoon season for interpretations. And we do visual interpretation of remote sensing data, not the digital image processing. You see this satellite data, this give you a synoptic view of the area. And you see this red color, this is the forest area, and light red is showing the agriculture area, and these are the fallow lands. And you see, you can see also the drainage lines or river line. So, and there are various drainage patterns are there. So these drainage gives you information about the slope also, because if more the drainage, you can say more the slope is there. And vegetation types you can see. But I also want to prepare the soil information what is underneath of this forest area. Then what it's it says that directly we cannot get information about the soils. Our purpose is here that directly remote sensing doesn't give any soil information. Remote sensing provides you the idea that where to take the soil sample. So we want to make the land unit area, we need to map it to decide that the land area is similar in its soil type. So if you see here, this is one satellite data is shown you, that is one alluvial plain. And you see this river is flowing. Earlier it was flowing like this one, and now it is flowing like this. But if you see this red color and this red color, both the places the red color is same, reflectance is same, but soil is not same, because here the soil is formed because of the active formation of the by the river. But here the soil is away from the river, it having the different parent material. So soil changes, soil similar reflectance does not mean similar soils. But we need to here the parent material is both the places are different, that's why soils will be different. So the first task is to map soil. That is your parent materials. In general, standard soil survey maps are prepared at 1 is to 250,000 scales, 50,000 scales, and 1 is to 20,000 scales, that we call detailed survey, semi-detailed survey, and reconnaissance survey. And according to that, your remote sensing data of various resolutions are available. For example, if you are go for the detailed map, then high resolution satellite data, for example, list 4 we use. And if we go 1 is to 50,000 satellite data, then we go for list 3 data or Landsat data. But if you are going for coarse resolution satellite data, then we are using 80 meter or more resolution satellite data. So these standard soil survey maps are prepared, and accordingly the satellite data are selected. And these are the standard soil survey scales maps being used in the entire country by the ICR organizations. So questions come: how to map soils? It requires to understand how soils are formed. So we need to know first what are the factors for soil formation. So for mapping soils with remote sensing data, we need to map soil forming factors to achieve soil mapping. And then how we can map the soil forming factors, that I will discuss with you. You know, the soil is formed by the factors of soil forming factors are climate, organism, parent material, relief, and time. If you see that climate related with the temperature and rainfall, different climates, same parent materials under different climates will result different soil. Organism means land use, land cover. If soils in forest and soils in croplands will be different, even the parent materials may same. So land use, land cover, which is related with the organism. Parent material, we need to study the geology, landform. Relief means topography. Topography we can means slope aspects. We can very well see with your with remote sensing data also, and from digital elevation model. And time, how old the soils is there. So these 5 factors are there. But when you are preparing for any area, then only 3 factors are important. You can say the landform or geomorphology, which we call it is a parent material. This is the most important part. Second is the topography, and third is the land use, land cover. So land use, land cover is the third importance for me. So what we do for soil mapping, we go for the we call it is the visual interpretation for physiographic analysis, and we also now call it is soil landscape analysis. Soil landscape analysis, as its name says, that is you are mapping landscape from remote sensing data. How you can map landscape? Because landscape mapping will tell you that this area having the same type of soils, and then you can take the samples from any place. In you are, if you are working in a particular area or district, you can say for that area climate and time is constant, it is not changing. So we assume it is not changing, so we don't consider climate and time for the time being. We are depends on only 3 factors: landform, or geomorphology, that is parent material. So first you map with the remote sensing data parent material, then you map, further divide that area or unit into the top based on the topography, then you go for the land use, land cover, and finally you will get the soil landscape unit. So you can say the soil landscape unit is an area which is similar in terms of geomorphology, topography, land use, land cover. Now I show you that one pictures. You see the satellite data you are seeing here. Are you getting this satellite data? This is the 3D view, and we have projected in 3D. And you see this is the area is the hill, and this is the area which is the flat, or you can say the valley area. And you can see here also the slope map. DM, this is the digital elevation model. You see this is the higher elevations, but here this is the lower elevation. Now and this is the showing one water set, and for this water set I want to prepare a soil information or soil map. And then I will make this is the geomorphology map by interpretation of remote sensing data. I know this is the area. Yellow color you are showing the valley area, and this green color is showing you the pediment area. So valley, pediment, and hills. This I divided the I interpreted the remote sensing data or FCC in the geomorphology unit. Then geomorphology unit was further divided based on topography or based on slope information. So this area, this red color was having the hills with the steep sloping. So and this area having the only the same valley area, same slope class. So it is not further divided. So where you find that is the hills were having two slopes, that's why hills have been divided into two slopes. Then it is we divide further on the basis of land use land cover. So we integrate the land use land cover in that area. So it land use land cover, agriculture, scrub, and our area in that watershed. After making these three informations together, we make it is a physiographic map or soil landscape unit. The satellite data now it is interpreted in this map unit. So this map unit, green you are seeing, it is the area having the valley fill area, and this is valley fill with agriculture, and it is the pediment with agriculture. This is the pediment with scrub land, this color. So you get this type of interpretation or map units. Now the similar color is showing that you can take the soil samples at any place, and these soil samples will be representing the characteristics of the entire area. If you have taken in the yellow area the soil samples, 3 to 5 soil samples you take in that one, and then this your soils will be similar to the entire area. Another examples I show you this case study. You see this is a one study area where this is the river is there. This is your hills is there. This forest area is there. Now I want to prepare a landscape map units using satellite data, and it is shown here the elevation map. You see the elevation map is showing that here is the slope is around 800 meter, here the slope is 600 meter, and here around 320 to 460 meter. So elevation is changing means slope is changing. So here you can get one type of slope, here another slope, here another slope, and entire area. First we need to interpret the landform. So I have interpreted the landform, parent material. You see the geomorphology. So this is the hill, this is the Piedmont plain, foothills you call, and this is your alluvial plain, young alluvial plain, or this is your flood plain. Near to the river it is floodplain, and away from the river this is the young alluvial plain. So you see this is the remote sensing data, this river, and how the both the things are different. Here you are seeing the different tonal variations. We call it is when we interpret the remote sensing data, we see the pattern, we see the association. So pattern and association is showing this is soils here is different, here is different, because this is the river drainage, river channel. So this parent material at this place and parent material at this place will be different. So we map first the parent material. This is the parent material 1, this is the parent material 2, this is the parent material 3, and we are calling is floodplain, alluvial plain, foothills, and hills. Now we want to integrate the information or divide the hill or Piedmont plain based on the slope classes, and we see that is the elevations you are seeing, that is the elevation was different, and even we can see the drainage pattern, and drainage pattern helps us to identify the slope where the drainage are meeting. You see here the drainage are meeting, then it means from here the slope is changing. So this place, this place, this place, you can see the slope is meeting, drainage is meeting, that's why the slope is changing. So you can here is one slope, here is another slope. So now what we have done, hill divided into the based on the slope, H1 steep slopes, H2 moderate slope. Piedmont plain, you divided the upper part. This is the slope was different here. Slope was here different, where I show you the elevation was changing or drainage was also meeting at this place. And this is the um, Piedmont plain 4. And this is the alluvial plain and so you have divided this one, and now it is geomorphology and slope map. And this, so satellite data was divided geomorphology slope map means, if you take into account this one, then this much of polygons are there, this much of similar type of soils are there. It is means P2 means this having the similar type of parent material and slope. Now I go further, third place. I will divide. After that topography, I will divide based on land use, land cover. And you see, that is this area which is having the P2, that is the Piedmont plain, P2. Now it is P2 forest and it is P2 agriculture. So by integrating systematically, if you interpret first parent material, then you divide further on the based on the topography, then you further divide based on the land use, land cover, then you will end or you will get the physiographic map. So from the remote sensing data, you get the physiographic map, or you get the soil. We also call it as soil landscape map. Still, we don't know about the soil, because soils we can get only when go to the fields and collect the soil samples. If we are not going to the fields and not collecting the soil samples, I don't know what type of soil is there. So if this remote sensing data is used only to delineate soil physiographic units, and this is the standard technique used throughout the world. It is the standard technique being used by National Bureau of Soil Survey, Land Use Planning, Soil Survey Department, or USDA. Everybody is using the same technique. So you have to remember that you have to, it is very easy to make the soil landscape units. You have to interpret it systematically, first parent material, then topography, then organism. Parent material, sometimes we can take the geomorphology map or geomorphology map of your study area, and you can get the geomorphology. You can further divide based on the slope, using seeing the drainage pattern or seeing the elevation map or digital elevation model. And then land use, land cover, you are very well seeing on the satellite data. So it helps you to prepare the physiographic map. Now, then what to do the second work? That now we select a sample strip. White line, it is showing the sample strip because road is going like that one in this area. So now you go and take the soil samples. If you are interested in surface and subsurface samples for fertility or for only water set management, then you can go only surface and subsurface soil samples. If you are going for soil, standard soil, preparing soil map, as soil survey organizations used to do, then they go for the profile study. So you do the profile study or soil sampling at this point, and you are taking here this soil samples. It will represent the entire area, this one. So that's why I say that is remote sensing data helps you to identify the sampling location, and it helps you to find the how much area this land, this characteristics will implies, or it will be valid for that one. So the basic concept is that what we have done, we have delineated the landscape unit, and landscape unit means you have delineated one area, and this area we say that is the it having a number of paddons, but those paddons are similar. That's why we know as a polypaddon. But we study only a point observation that we call as a paddon. So paddon or it is a soil sampling unit, but polypaddon is a soil mapping unit. So you can say, well, so soil landscape unit is a mapping unit for soil. So this is the soil profiles when we study, and you have also studied earlier that is A layer, B layer, and C layer. So soils are composed of various layers we know as horizons, and on these horizons we characterize and we collect the soil samples of each horizons. So soil mapping is the then you take this soil profile, you analyze the morphological characteristics, physical-chemical characteristics. Then we classify the soils according to the USDA soil taxonomy to give its a proper name, scientific name. And after doing this one, then you finalize the soil map units. Soil map units be again redraw, because if we find that the units, the lines, what polygons we have prepared may not correct, so we remodified this one. And then we do transfer on the topo sheets, and this soil map is ready, and then we can go for the land use planning purpose. So the three steps are there. First is the visual interpretation, which you can do in your laboratory or in your office. Then go for the field survey to collect the soil samples or profile study. Then come to the office to post field interpretation. You finalize your soil, analyze the soil properties, and you classify the soils. So in the soil survey, we take the sample strips. You can take one or two soil samples strips in there, where you can do in detailed soil survey study. If you are interested in profile study, then go to 1.5 to 2 meter depth of the study. Otherwise, you go for surface and subsurface soils and make the observations. So how the soil is changing, I'm just giving one example and transect that you can see. Suppose this is the area same, that is the hill, the mountains was there, and this is the foothills, Piedmont, and these were the alluvial plains. If you see, the gradient was like this one, and you know the soil, when coming from the hills, materials get deposited at the lower slope, so soil gets changed. So you can see in the photograph that is, this is the mountains, hills, and this is the agriculture fields, and like that one we do the soil profile study. So this is the, we make a pit up to the parent materials, and we study the different layers of the soils. So you can see, this is the on the hills, the soils were like that one, you are getting the stones also. But when you go just foothills in this agriculture field, then you see the soils are having stones but small sizes. So profile get changed or soil get changed. So how we get so you can see that is the your landscape unit is changing, then soil is changing. Here you see that when you are coming to the flat lower Piedmont area, means then you see the soil profile, and here no stones are there. Means the soils are very well, very fine texture soils is there. But when you go to the river near to the floodplain, in the floodplain you see the soils are sandy in texture, and even stones are river beds, stones are you are getting. So in you can see that is the, as a landscape unit is changing, soil is changing. So we need to take few samples, but those few samples should represent our area, and we can do this one with a with the visual interpretation of remote sensing data for interpreting soil landscape units. So you see, this is the map units, which your landscape map units you have related H1, H2, HP1, P2, P3, and in this one we have collected soil samples and analyzed the texture, pH, depth, drainage class. Similar, many soil properties can be analyzed: nitrogen, phosphorus, potassium, or you can go for another micronutrients or any properties. So for example, it is shown that is the physical properties that is of various map units you have got, and then soil map is ready for use, and you can use this soil map for land use planning. This is the physiographic soil map or soil landscape unit map. You see, this is the prepared 1, 2, 3. This is map units, this is the mountains, and this is the Piedmonts. So like that we can prepare. So I can summarize that is the soil mappings you can do by visual interpretation techniques, methods using remote sensing data. Ancillary data, you can take the topo sheet, you can take the geomorphology map or any published literature's informations, develop interpretation key, and then you prepare the landscape unit map, and you will develop the ground truth, do the ground truth collections, study the soil profiles, analyze, and post-field interpretations, prepare soil map. Like that one, soil map is ready, and if this map, or you can get the soil map prepared from various any other survey organizations, that also you can use that map, and this map can be used for further land use planning. In the land use planning, what we do, that is we do the land evaluation. And in general land use planning, the various land evaluation methods are available to assess the potential and productivity of the soils. In general, we are using land capability classification. You are already aware that one. Then land irrigability classification, FAO framework of land evaluation. FAO framework of land evaluation is used for your that is suitability of soils for various crop. So for agriculture crop suitability assessments, we use FAO framework of land evaluation. I am here showing the land capability classification or land capability map, how you can prepare with this soil map. So you know the land capability classifications, where we say that is the land is divided into 8 capability classes, ranging from we depict it as a capability 1 to capability 8. So capability 1 class to capability 4 is suitable for cultivation. Capability 5 to capability 8 is suitable for not suitable for cultivations, for it is suitable for forestry and other uses. So what we do, you have the land capability criteria, you have the soil and land characteristics, you have prepared the soil map, and you are having the soil and land characteristics, so you match both. So you compare both, one that is the match the properties, and you give the land capability classes. So if I see that is the land capability criteria table is like this one, which we follow in India. The texture, you know, the if capability class 1 is there, then texture should texture of the surface and subsurface should be following this textural class: clay loam, loam, sandy loam. Depth should be more than 90 centimeters, slope should be 0 to 1%, and erosion should be even. So like that one, this criteria we used to take, and based on this criteria you compare with, because of each soil map unit, now you know the texture, you know the depth of the soils, you slope, you know, so you can make the land capability map. So this is the soil map was converted into the land capability map. Here you can see this land one, this is the land capability class 1, where the soils are suitable for for any crop or intensive use for cultivation. But as here you can see, this is the capability class 2, having the limitation of soil. Here the capability class 2 having the limitation of water or erosion, capability class E and ES. So capability classes, then capability subclasses depicts the limitations. So in general 4 type of limitations we used to consider, that is the wetness, climatic conditions, erosion, and soil limitations. Erosion, soil, and wetness limitations we used to characterize at the subclass level. So this is the simple way how we go for the prepare the land capability map, and based on the land land capability you can go for land use planning. In general land use planning means where we go for the conservation agriculture, and conservation with which limitations that you can make plan for that one. Similarly we do for the evaluate for each each soil map unit for land irrigability classification, and you know the land irrigability criteria is also soil and land irrigability class criteria are available with literature, so we compare that one and we do. Third is the FAO suitability, crop suitability analysis, and that is the soil suitable criteria for crop suitability is also given in the literatures, and we compare and we do. And today we are doing in programming also, that we define in the criteria in the computer programs also, and classify the map units. But the first questions come, how to prepare the soil map. So soil mapping in general is prepared by the interpretation of soil landscape units. Now some of the things I can discuss with the degraded land mapping. So we you know that is the degraded lands, we characterize the physical degradation, chemical degradations, and biological degradations. And physical degradations means the erosion, water logging, soil compactions. And chemical degradations salt affected soils comes under that class, and soil acidity, which we cannot map with the remote sensing data, but salt affected soils we can map. Biological degradation generally we also cannot map with the remote sensing data directly, so we go for the it is represented by the loss of organic matter. Eh, you know that is in India, that is total 120.7 million hectare has been characterized as the that is or degraded lands in India, and major land degradation occurs because of water erosion and wind erosion. So water erosion more than 10 tons per hectares, that is our arable lands, that is 73 million hectares. So total water erosion, water or wind erosion is 85.67 million hectares. So we will see some of the satellite data that how we can see this erosion. You can see that this is the satellite data which is shown of the of a area. This is the Shivalik Hills, and this is the foothills, or and you are seeing this is the Yamuna River, and in this you see that is the here because you know the water erosion means removal of the top layers, and if top layer is removed, then your fine clay particles, organic matters will be removed, then it sandy materials will left on the surface, sands will left on the surface, so it will give the high reflectance using remote sensing data. So in the false color composite, it will high reflectance area will showing as a more erosion. So one is that is you see this in this hills. Here you are getting a lot of drainage lines, and you know the number of drains or drainage density is high, then it depicts that is the severe erosion conditions. Although it is under the entire hills is under the forest, but one thing you see, this is the ridge line, and this is the south aspect of the hills. In north aspect, this is the north aspect, and north aspect you see the bright red and dense forest cover. But here you see the as the aspect changes in the south part, you can see that is having the forest is not as bright red, and it is not smooth, so density of the forest is less here in south. So in the hills, south aspects witness more soil erosion, and north aspect witness less soil erosion because of the temperature or moisture content in the soils. That's why north aspect having high soil moisture content, and because of that vegetation growth is very good, and they allow less erosion. But in this south side, erosion is high, and you see this is the drainage pattern. So we characterize the very severe erosion, very severe erosion. But here the drainage density are not so much. So this is the, you can say this may be very severe, but this may be moderately severe erosion. But here you see, as the river is here, you are seeing this is the top layer is removed, the moderate erosion, and here you are seeing that is the slight erosions. If you can see in this pictures better, that is a very severe, very severe erosion, very severe erosion, moderate erosion, and slight erosion. So remote sensing data, you can make the image enhancement analysis as well in digital image processing, and then you can see you can enhance the surface features. And seeing the surface features means rills, gully, because in the in the very severe erosions, here with you in moderate erosion you will find the top soils is eroded, but here you will find the gullies. So gully lands can be identified, and we can characterize into the various salt affected various eroded soils. If we see the salt affected soils, how they appears on the remote sensing data. So this is the you see this is the list Indian remote sensing satellite 5.8 meter salt, that is false color composite, and this is the picture taken of Mathura district, and in the field you see the salts how they are appearing. Surface becomes white surface, and they give the high reflectance on the satellite data and you can see this is the salt affected soils. And here this is the moisture, you are, because of moisture it is giving bluish tinge, and this is the waterlogged area. So waterlogging salt affected soils we can see very well with the remote sensing data. Actually land degradation appears, land degradation process appears on the soil surface, and soil surface your electromagnetic radiations or coming to the surface, they get interact with the surface. So degraded lands mapping is very easily we can map with the remote sensing data. We can use a direct interpretation of remote sensing data. But in the normal soils, soil mapping is a, we have to go the soil landscape analysis approach. Here you can see this is the waterlogged area and how they are appearing in the satellite data. So it has been seen that the saline sodic, strongly saline sodic soils give the high reflectance, and this gives the low reflectance. And normal soils give the low reflectance. So reflectance characteristics changes with the amount of salt present on the surface. If salts are high amount is in highly saline soils, so it gives the highest reflectance. If it is the moderate amount, it gives the little less reflectance. So we can characterize that one is the change in the tonal characteristics. This is the salt affected soils you see in the Uttar Pradesh area, a large area. You can see all the white salt affected soils are there. But in the Rajasthan, you see this is the means one channel is there, means this is the water depression land is there, that is the paleo channel, means lost river. Paleo channel is there, and this is water logging, and this is the salt affected soils. But this white you are saying, this is the sand dunes. So these are the sand dunes. It is a area is of Indira Gandhi Canal Command area, and this is a canal. This is showing the canal, and this red color it is showing the agricultural land, cropland. So different features you can very well map with the remote sensing data. Even Indian remote sensing satellite data, that is your high resolution satellite data, we have mapped in one, because they are in the Rajasthan, chuck boundaries are there, and you can see this is the waterlogged area, this is the salt affected soils, and this is the cropland. Where, but do you know that this area also saying the cyan color, that is having partial waterlogging, means water is not on the surface, but soils are saturated with water. That's why you are getting the cyan color. So we can characterize that is a waterlogged area. It is the moderately waterlogged area is there, and this area moderately waterlogged area, that may also in futures get accumulation of salt, and it will convert it into salt affected soils. So you can see the entire Indira Gandhi Canal Command area, the various places they are waterlogged conditions have been generated. We can use the remote sensing data for monitoring the land degradations also. And here you can see 1975, you see the land satellite data. This one is the one paleo channel or river bed, old river course. And you see that is how in 10 years this river water has appeared in this one in river channel. And you see 90, then it becomes like entire area. And in 1995, it becomes as a channel. So water logging in 70s, this Indira Gandhi Canal Command area was introduced, canal was introduced, and after that, in the some of the pockets in the low-lying area or paleo channel area, we are getting the water logging conditions. And remote sensing data, we can very well monitor those things with we can monitor using remote sensing data by taking temporal remote sensing satellite data. Now I come to the at the end, that is the today lot of scope is going to be in digital soil mapping. Earlier I told you that how we are doing the soil mapping, conventional methods, traditional interpretation of soil soil remote sensing data for soil mapping. That was soil landscape analysis approach. But today, digital soil mapping is coming into the pictures, and how we can do this digital soil mapping, because today lot of remote sensing data, you are having the remote sensing data, you can generate various spectral indices, spectral indices, you can generate, you have the digital elevation model DM, and you can generate terrain indices. So DM, terrain indices, spectral indices, and you are also having the geology informations or other ancillary information. So you are and you can have lot of soil information. You can collect the soil information as grid wise, and you can these data we can make a relationship statistical analysis, and by statistical analysis we can go for the predicting the soil properties. I just show you one example how we are doing this one. Suppose this is one watershed, and regular grids we have taken the soil samples. So it is showing that the soil samples are taken at 250-meter by 250-meter grid in this watershed. So collected this one 113 samples in cropland, flowerland, orchard, dense forest, moderately dense forest, all type of terrain. And in this area we have generated various terrain parameter, terrain index, which I have not discussed here, because terrain index is how to generate. We can generate elevation, slope, upper catchment area, terrain wetness index, soil means that is a SPI index, STI index. So from the DM we can generate, and we found that is terrain wetness index is very much correlated with the carbon content in the soils. So if I want to prepare the soil carbon distribution map, so what I can do, that regular interval you take the soil samples, and you generate the terrain and spectral indices, taking the satellite data and digital elevation models, and you can prepare the spatial distribution map of with the total carbon. So this is the we use the geostatistical methods, or co-kriging methods. So here co-kriging was used because we use the NDVI satellite data, means vegetation index, NDVI vegetation spectral index, and terrain index to integrate and prepare the digital soil map or digital carbon map. So with this, I thank you all for joining these lectures, and I hope that I may have given some basics of how we can use remote sensing data for soil mapping. If you have any questions, you can ask me or at now. Yes, are you getting me? Hello.
Hello, sir.
Yes, I have.
Sir, there are some questions in the chat box. If you can address.
Okay, okay. How many times left to give me certificate? If the indices can help us to categorize soil types, sir, can we identify the accuracy? Yeah, one question is that indices can help us to categorize soil types. Actually, indices prepared from the satellite data we know as a spectral indices. For example, soil brightness index, soil color index, and these indices are used for digital soil mapping. It is not can be used for soil landscape analysis. I told you here the soil mapping procedure, how we can map the soil. So we go for the soil landscape delineation, or how we can prepare soil landscape unit map using remote sensing data. So soil indices you can use for mapping, digital mapping of soils. Sir, can we identify the acreage of waterlogged area? Yes, because you have seen that satellite data, we are seeing the waterlogged area of different, because waterlogging gives the dark bluish tone, and if waterlogging is less, then bluish tone will be little less. Then changing in the tonal variations, we can map the different highly waterlogged area or moderately waterlogged area. And if you from pencil on tracing sheet, if you take the satellite data on your in the GIS software, I told you there are today various GIS softwares are available. We can open the satellite data in GIS softwares, and when we do georeference the satellite data, that one we can map that one. And if you mapping that one polygon, then you can identify the area. It will give you area. Sir, riverbed and salt affected areas are look similar in image. Do we have any specific DN values or spectral reflectance value for salt affected soils? Actually, salt affected soils and riverbeds, sure, it appears similar, white is in tone, but you know the riverbed and the location of both the things, both the objects are distinct. Salt affected soils may not occur along the riverbed, it occurs in the mainland. So it will be so you can identify because in image mapping we do the tone, texture, pattern, and association. So as a association is important characteristic, so you can find out it is not associated with the riverbed. And river, and another, if you see the DN value, riverbed gives the high DN values because of sandy materials, but salt affected soils gives lesser than the riverbed material. So DN value will be different. It will be not say almost 10, 15, or DN value difference maybe around 20, 25. So it is not same. It appears on visually when you are doing, then it appears same, but when we go for digital classification, it appears different. Organic carbon value obtained from satellite image is how much reliable and what level it varies with OC samples analysis. This organic carbon, we have mapped the organic soil organic carbon map using remote sensing data. In general, uh, it is reliable, but when we say the correlation coefficients we are getting 0.7 or 0.8, not more than that. But you can say that is from organic carbon content can be mapped uh, very means significantly very good with remote sensing data. And today people are using hyperspectral remote sensing data in place of the multispectral remote sensing data. Can we access the depth of water in water bodies? If so, can calculate the available water in water. And depth of water we cannot measure with the remote sensing data. But one thing I tell you, that if water depth is more, then you will get the tonal variation. Tone will be distinct, very different than where the depth is less. So depth is changing, water depth, then its reflectance also you will get the change in the reflectance, and therefore the variation will be there. Your tonal variation will be there. So you can say you can but directly remote sensing data not giving you the depth. You can say this here the depth is more or different, here the depth is different. And once you measure the depth there physically, then you can correlate, that is yes, this is the you can link with the depth information. So you can see that is the depth directly we cannot measure with the remote sensing data, but some scatterometer or some other river water body depth are measured, but it is not discussed here. What about other nutrients? From the remote sensing data, you can link with the soil carbon, nitrogen, and micronutrients we cannot map because micronutrients correlation coefficients comes around 0.3, 0.4. So it is not very much advisable to map with micronutrients. But NPK and organic carbons we are using to map the soil with remote sensing data, but also these are used with not multispectral but with a hyperspectral remote sensing data. Yes, I think there is no questions now.
Thank you, sir. Thank you for this comprehensive and valuable lecture, sir.
Okay. And now our other colleague, Dr. N.R. Patel, is I am seeing him, so he will take the lectures at 11:45.
Okay, sir.
Okay.
Thank you very much, sir.
Okay. Thank you.
Hello, everyone. In our lecture series, there is another lecture that is on crop discrimination and acreage estimation. We welcome Dr. N.R. Patel, sir, from IRS Dehradun. He will giving us lecture on this topic. We welcome you, sir. We request you to please start the session, sir. Dr. Patel, sir.
Hello, am I audible?
Yes, sir.
Yes,
Your
yeah.
voice is audible.
So we'll start lecture around 11:45, 11:40 something. Okay. So before that, okay, I would like to interact with some of the participants. What is their expectation mainly with respect to remote sensing application in agriculture? What is their background? Little bit, okay, one by one people can tell. Or coordinator can brief about, okay, what is their expectation, what actually their background, what kind of knowledge and skill they have.
Sir, the audience is primarily the PG and PhD students, and also the faculty member is also there. So they have a little bit knowledge of remote sensing, but they don't have advanced knowledge, sir.
They don't have advanced knowledge.
Yes.
They have knowledge about remote sensing, basic.
Yes, sir.
Yeah. So, but agriculture, maybe most of the people must be with the background of agronomy or like that, or agriculture background.
Yes, sir. All the disciplines are present here, sir. For agriculture side also the students are there. In engineering side also the students are there in the session.
Okay. So now, can you see my slides?
Yes, sir.
Can you see my slide?
Yes, sir. It's visible.
Okay, okay. So let us start. Okay, how remote sensing can helps in agriculture with major emphasis on crop acreage and discrimination. So first of all, we need to understand how remote sensing works and why it is so much important, particularly for agriculture. So if you look it to past almost more than 3 decades, you may see there is a huge potential of remote sensing in agriculture, and this can be evidence mainly from different kind of publication, reports, even the operational application being realized in India. So more than 60 to 70% of application with the satellite or satellite remote sensing data is being realized particularly for agriculture. So there is a gamut of application ranging from simple discrimination of crop to crop insurance and decision support system in agriculture. So there is a large number of application. So it accomplishes almost 60 to 70% of application potential, not only for the researcher or not only for the government department. Nowadays, you will find this remote sensing being utilized for agriculture sector in agri-business model, like crop insurance, even identifying optimal cold storages, food production park, food processing industries, all different. Okay, what is requirement of today to double the farmer income? is being done or being geared up with the use of technology, particularly space technology. So we'll go into detail about how agriculture. All of you must be knowing that there is a lot more pressure is there, environmental and human pressure, which lead to degradation of land resources, and which is finally affecting the quantum jump in the production, what we realized during green revolution. So basically all of you know that 70 to 80% population depend on agriculture. That is why agriculture is very much important, and it is a backbone of Indian economy. It has been contributing heavily, but if you see 1990s, contribution of agriculture enterprise was almost 37% to the gross domestic output. But today it has declined because of certain service sector and industrial sector has gained. But even though rural population largely depend on agriculture only, so we need to now work towards upliftment of the life and livelihood of the population, those who are living in the rural India. So Indian agriculture, if we look at the statistic and fact, almost more than 60 to 180 million tons, million hectare land is there for agriculture. Net irrigated area almost cross 60% of area is under irrigated because of very vast development with respect to the irrigation dam and many irrigation project. Agriculture contribute 30 to 9%. But nowadays, if you see, earlier food grain production, there is no issue. We are self-sufficient with respect to food grain production. It has now touched to the 280 million tons almost in India. But at the same time, nowadays, horticulture and pulses. Horticulture production has crossed almost 300 million tons. And also pulses quantum jump is there by 25% in the pulses production. So now India is looking not only with respect to the self-sufficient with respect to food grain for agriculture produce, particularly food grain, but we are now looking more towards the ensuring nutritional security to increase through increasing production of horticulture as well as pulses and oil seeds. So we need to have a balanced approach, not only the food grain production, we need to have a very good nutritious food in terms of pulses as well as horticulture, fruit and vegetables. So diversity, why remote sensing? Of course, highest number of applications are there in agriculture, but even though we are limited to certain extent because of our heterogeneity in the Indian landmass. If you look at India, we'll find large degree of diversity with respect to the landform, with respect to the climate regime, because our climate ranges from arid to humid almost. There are 250 mm rainfall in the Churu, Bikaner and even western Rajasthan, to almost more than 2000 mm rainfall in the North India, some hilly station. So there is large degree of variability is there with respect to the climate regime. Then also physiography. We have mountain, we have rock outcrop, we have desert, we have plain, we have floodplain, we have peninsular. So there are different kind of landform are there. All those have different kind of ability to support the agriculture. And at the same time, soil also you can see we have soil that varies from the alluvial, black, red and laterite soil. There is a cotton growing belt in the South India like Maharashtra, which require black soil. Then also red soil is there in peninsular India. Alluvial plain is there in Indo-Gangetic plain. So these all support different kind of agriculture. So which you can see in the right side, there are different kind of agro ecosystems are there. Mountain agro ecosystem, coastal, desert and also plain. So in plain also you will find rice wheat system, then groundnut, pearl millet based system, there is a cereal tree based system, groundnut in the Gujarat, and also there is cotton-based system. So there are different kind of cropping systems are practiced across India. So what I want to pinpoint here that there is large degree of diversity with respect to the agriculture being practiced by the farmer. So it is, there are more than 200, 300 crops are there in the rotation manner. So it is very difficult to have a one single solution from remote sensing to get the crop acreage and discrimination. Because different kind of crop, even though beyond crops, you'll find different varieties also. Short duration, long duration varieties. So all these different varieties, different kind of cropping system like intercropping, mixed cropping, all those require different kind of approach to discriminate crops. So it is very challenging and huge task in front of scientific community, particularly those who are IT people or remote sensing scientists or remote sensing expert, to discriminate different kind of crops in India. Even though we have achieved a lot more for the agriculture sector over last 3 decades. So let me introduce you to the geospatial technology. What are the different kind of database and how it works? So particular satellite remote sensing, if you look at, there are different kind of satellite sensor which have capability to observe the Earth's surface because of difference in the electromagnetic spectrum. Reflectors absorption and transmitters is variable or different in the different spectral band of the electromagnetic spectrum. Because of this, there are different sensors which has got different spatial resolution, temporal resolution, and spectral resolution. Spectral means different number of bands, spectral bands. Spatial means ability to resolve or ability to measure on the ground. Sensor ability to measure on the ground, minimum distance on the ground. Temporal means how frequently you can have satellite image for particular area from particular sensor. Suppose it is a resource sensor, so it has got 22 days repetitivity for the least 3, but least 4 it may be having 6 days also repetitivity. So particular area, how many days you can have acquire or you can regularly monitor particular area with the same sensor, that is a frequent repetitivity or temporal resolution. Then another technology that has come up, that is a geographic information system. So geographic information system, it is nothing but it is a traditional system that has ability to input, store, analyze, and visualize both partial and non-partial data. When we apply to agriculture, it has ability to provide spatial dimension to the problems associated with the agriculture and reference, those problems which are reference and associated with the agriculture. So with the different kind of ground data, like those who are working with the agromet, like me, agrometeorologist, so we observe mainly the weather at different research farm station, agrometeorological observation. We collect also ground observation on the leaf area index or some soil moisture, all those things. So with the GIS, you can integrate satellite imagery with the ground in situ measurement, apart from the also in AWS or weather observation, and also all those observation along with the remote sensing data, you can integrate into a GIS for certain kind of ecosystem modeling, like modeling of for the yield, crop yield, which required some decision support tool. So with the remote sensing, you can have a partially explicit information about soil, crop type, and also soil moisture, leaf area index. All you can feed into the GIS, and you can along with the crop model, you can generate decision support system for the certain kind of application. Third technology is a GNSS, Global Navigation System of System. The navigation means that provides the ability to identify the location of the particular object. Now here, with respect to agriculture, like particularly if you know precision agriculture. Precision agriculture means we have to apply our input, both fertilizer, irrigation, or pesticides or weedicides, according to the needs of the crops within the farm field. So there is a variability with respect to the requirement of the fertilizer and irrigation needs within the field. So how you can optimize, how you can facilitate this? Because through GNS, we provide the location of your equipment where within the field, tractor within the field, then accordingly it can operate by the giving message or signal from the GIS directly to about the location of the equipment, and also database which is holding on the computer on the tractor, we can work. So that is an approach being practiced by in USA and Europe for precision agriculture. But that is not as on now possible for India. But GNS has got really very good capability for the even ground truth mapping, ground truth data collection through mobile application where you require GPS location. So all this technology, GPS, GNSS, GIS, and satellite remote sensing, if they converge, then they provide some informed solution for informed decision making. Solution with respect to decision support system, information system, you can make for pesticide application, irrigation scheduling, or some crop production forecasting, early warning. All those require integration of all these three technologies. So what is the state of different kind of sensor within India? That briefly I can say for land related application, as on today we have some satellite like Reset1 something. Now we have very good satellite which is going to be launched also very soon. Reset1, Reset2, then Reset2, Reset2A, and Reset3, which is going to launch. So these all are useful for the crop type mapping. Then we have also high resolution satellite with the less than 1 meter spatial resolution like CAAST. We have CAAST data that will now come into multispectral mode also. They also support the mapping of field boundaries and also field location. As at the same time, India has having a INSAT series of satellite and OceanSat, Saral, Altica, and SCARSat, which provide ocean related observation, and we have weather related observation like INSAT. So where you can get the temperature profile, humidity profile, you can get also rainfall. So these are weather observation which is very much useful for driving different kind of crop model to support crop production forecasting or early warning. So it is not like that only remote sensing that can bring all solution to the problems of farmer. We need to have in situ measurement, we need to have this satellite remote sensing, and we need to have a weather observation also if you want to really work and toward the upliftment of the farm livelihood of farmers. So today satellite data is available with the spatial resolution from 1 kilometer to almost 1 meter as per the needs of the user. So satellite remote sensing, there are gamut of applications. Already I told in agriculture, from land mapping, soil conservation, that horticulture crop assessment, cropping system analysis, pest disease monitoring, and also inland fisheries. So these are different kind of applications. But one of the most significant application is the crop production forecasting. India is one of the few countries which use regularly and operationally satellite remote sensing for regular update on the crop production statistic of major crops, more than 12 crops. As on today, crop production forecast bulletin is available for the major dominated districts. So these crops are we'll say in the later, but it is now satellite based optical and radar imagery are widely being used for the monitoring agriculture, and this all provide distribution of different kind of crop being practiced in different region, development, monitoring of plant growth and development, and identification of any crop departure like drought. if there is a drought, flood, how it is affecting the crop. That also you can assess with the multi-date remote sensing data. When this data integrated with meteorology and other in-situ observation, as I said, you can generate decision support system, you can assess water use, you can assess water use productivity, and other irrigation scheduling, all different kind of application you can envisage if you correctly analyze and use this data with the GIS environment. So let me introduce to the basic already. Okay, you may be knowing a little bit about remote sensing, but this is the mainly multispectral, how vegetation works or interact with the electromagnetic radiation. Mainly, all of we know plant require light for photosynthesis, and plant absorb that visible light, or you can say photosynthetically active radiation light, to drive photosynthesis or to make its food. So that visible light is nothing but blue, green, and red. So because of chlorophyll pigmentation, this light is absorbed, so reflectors will be very less. The next domain, that is a near infrared region from 0.7 to almost 1.10. That is a near infrared range. So near infrared range, because of this cell wall interface, healthy crop is there, then you will find more cell wall interface scattering. So multiple scattering will be there from this cell wall. As a result, you will find higher reflectors whenever crop is healthy or when crop is in good condition. Beyond, if you go near infrared, there are short wave infrared band, there are 3 water absorption band. So if crop is healthy, you will find more absorption of this short wave infrared wavelength. As a result, you can find less reflectors in this short wave infrared wavelength. So this sweep band, that is also very much useful for improving accuracy of different discrimination of different kind of crops, as well as monitoring water stress and agricultural drought. So nowadays, beyond this, okay, if even we go beyond 3, even we go beyond these 3 micrometer wavelength, there is a thermal infrared TIR wavelength, that is and generally up to 14 millimicron. So thermal infrared, that is very much useful, particularly for detection of the heat stress. Hello. Who is? I am doing lecture. Hello. So sorry, okay, some disturbance, some call is there. So further, okay, how we can use this near infrared and red, mainly the visible and the near infrared wavelength, that using combination of both these reflectors, we can able to generate normalized difference vegetation index. So you can see here on the left side how it works. If green crop is there or green vegetation is there, it absorbs more in case of visible light, that is photosynthetically active light, radiation. So its reflectors will be hardly 8%. And in near infrared, if it is a healthy crop like green crops, reflectors will be always more than 50%. So finally, if you put in the equation of normalized difference vegetation index, you will get 0.72, means more than 0.7 NDVI. But if same crop is stress crop, it is not okay adequately watered, or it is a stress vegetation, yellow, then okay, you will get higher reflectors in the red wavelength, that means 30%, and decline in the reflectors in case of near infrared wavelength. So finally, it gives you a NDVI value around less than 0.15. So this way, okay, this is NDVI is computed, and this normalized difference vegetation index or any index, if you get the multi-day data like okay Modi's or like okay Sentinel, all data is available, which are available on a weekly basis. Even our advanced sweeps data, that is available every 5 days. So using this near infrared red wavelength region band of the advanced leaves. You can generate almost weekly or fortnightly this NDVI images, which can be useful for monitoring crop growth, development, discrimination, finally yield estimation also. So let us understand how basically we can discriminate different kind of crops. Particularly different crops has got different kind of canopy architecture, color of the leaves, crop geometry, spacing, row as well as intra-spacing of the crops. They have different inclination of leaves, orientation of leaves. There are aeroprofile canopies, palmopile canopies. Then there is also biochemical composition of crop is different. Crop height is different. Then also crop biomass is also different. Means leaf area cover is different. So all these canopy characteristic of crops which differ among the different kind of crops as well as varieties of particular crop, and all these affect the signal or signature, which is mainly the difference in the amount of radiation interaction with the leaf, which result into the different kind of energy being absorbed, transmitted, and the reflected within the electromagnetic radiation spectrum. So finally, because of this difference in the reflectors, you will find, suppose here this is a one state. Okay, you are finding here particularly this one example of the reflectance curve for the first week of March in Haryana. Now you see the Haryana in March first week, you will find three crops. Mainly one wheat, which is in the maximum vegetative growth stage, maximum pre-anthesis stage. There is maybe a mustard, almost which is in maturity stage. Then sugarcane, you will find that is almost harvested. Only some stubble is there or some stem is there, which is left for the ratuning. With that sugarcane you will find in the Yamuna Nagar or some nearby area, Karna. So because of this different phenology, harvesting time as well as sowing time and different attainment of the maximum growth stage, you can see here the reflectance, highest reflectance is there for near infrared region for the wheat crop, because it is in the maximum growth stage. So it is giving a higher reflectance in NIR, followed by mustard. The mustard is almost in maturity stage. So green leaves are there, little bit green leaves are there. But for sugarcane, there is no leaves. All traces are left in the March. So you'll find this kind of reflectance pattern, particularly for three different crops. So with the NIR band here, you can see all other bands, this little bit difference is there, but major difference you are finding in the NIR region. And this can only enable you to discriminate these three crops in a Haryana region with single date. So with single date, you can even classify these three crops in Haryana if you choose right time for the satellite image acquisition. As I said, so crop type, the identification and or discrimination and acreage estimation is different. If your interest is the crop identification or acreage discrimination, then you should have different kind of approach. Like crop discrimination that require your emphasis shall be more on the classifying all crop types from each other. Means you are trying to distinguish each and every crop which is grown in a particular region. Then it is called crop discrimination or crop identification. But if your objective is to make acreage estimation or to estimate acreage of particular crop in a block or a particular district, then your emphasis of adopting acquisition of satellite image or applying approach, digital imaging approach, all with the emphasis on the particular target crop. Suppose you are interested to estimate acreage estimation in the Bhopal. So Bhopal mainly you'll find, okay, this wheat which is reached to the peak growth stage, particularly in the mid of February. So in Bhopal, mid of February, you acquire satellite image of lease 3 you can get the best accuracy for the wheat crop. Because other crops like, okay, mustard is also little bit about, mustard is almost in harvesting stage or harvested. So dominant crop you will find in the mid of February with the luxuriant vegetative growth stage, that is a wheat crop. So you can easily discriminate wheat crop with the satellite data acquisition in the mid of February. And for other crops are there, you are not bothering much about their accuracy. So all you try to improve accuracy of wheat crop only and get the best acreage amount with the best approach, whether it is a multi-date satellite data, single data, or the some other ground truth specific to the particular crop. All you emphasize on the wheat crop. Then only you can get the best acreage estimation for particular crop. So here you see there are different kind of approaches are there. There are different kind of approaches. Hello, if you are you listening? Hello? Hello?
Yes, sir.
Yes, sir.
Are you receiving? Because there sometimes it is problem is that it is log out.
No, sir, it's visible, sir.
Okay. That is why sometimes you make some interaction. Okay.
Yes, sir. Yes, sir. It's visible, sir.
Okay. So here too, there are two methodologies are there for a crop acreage estimation. So in India, mainly in 1990s, early 1990s, there was a one project envisaged, that is crop acreage and production estimation by Ministry of Agriculture and the ISRO, mainly Space Application Center. Under these two approaches were envisaged. One is a boundary overlaying approach, another is a stratified sample segment approach. Particular boundary overlaying approach, that means suppose it is for some academic or some research or some training purpose. It is applicable only for the small area, small administrative unit like block or tehsil or district. Under this approach, mainly you acquire satellite image, particularly during the right time of satellite data acquisition, like as I said for Bhopal or Madhya Pradesh, where our wheat crop is grown early, so it reached to the maximum vegetative growth stage, particularly in the mid of February also. So you acquire during mid of February, you can get best acreage for the wheat crop. But for approach, first you acquire satellite image multispectral with the blue, green, red, and near infrared band, or green, blue, red, near infrared and SWIR band, 4-band image like list 3, which list 3 or list 4. Okay, so list 3 you acquire image. Then after acquisition of this satellite image, boundary of tehsil or boundary of district, we digitize vector layer. With that vector boundary, AOI, you generate AOI. With the AOI, you can mask all pixel, all satellite pixel or image pixel within the boundary. That means you are masking the whole satellite image which is available by particular vector boundary. After masking vector boundary, you already, here one thing one should keep it in mind for agriculture application like crop acreage, all these things, because it is a very high amount of application or a large number of application are being practiced in agriculture, but at the same time it is very challenging also, because you need to have a ground truth information in a real time basis, like that whenever there is a satellite pass is there, you have ordered satellite data to the NDC from the NRSC based on the path and row system. Once you order satellite data, particular date like mid of February, so you shall plan ground truth observation date, all these things before February. Then you go to in the mid of February to the field, acquire ground truth information about the wheat crop or what are the other crop practice, what are their stage on the ground, what is their sowing dates. Also, you take certain other observation of LAI, height, or other like phenological stages. all those observations you collect during the field time when satellite pass is there. After collecting this information, you come back and you train this satellite image, you classify with the maximum likelihood classifier or unsupervised classification. So maximum likelihood classifier algorithm is nothing but based on the probability of to be a part of the or to be a member of the particular class, depending upon the probability, maximum probability. We classify particular pixel. So once you come back with the ground truth, you identify those ground truth data or those crop types, its location in the satellite image itself. You identify those locations with the GPA, whatever collected with the GPS, identify in the satellite image, then use those ground truth information for training the maximum likelihood algorithm. Once you train this algorithm with the statistic generation, you will find finally the classification. Like here, one example what I have shown, that is for Kolhapur district in Maharashtra. So there, we have classified sugarcane crop, paddy crop, sunflower, groundnut, and coconut. There are natural vegetation or current fallow or other kind of vegetation. The main crops were 4 crops. So we could able to classify, because if you have got very good ground truth, at right time of satellite image acquisition, you can able to classify all these crops. So this is another what I have shown told earlier, that single date advanced image with the rigorous ground truth. We have acquired this image in the March first week. We could able to classify that. You can see sugarcane, wheat, and mustard. So mainly yellow is your wheat crop, and mustard is a pink, and that some blue shade is in the Yamuna Nagar, that hill part, that is a sugarcane. So we could able to classify with the certain accuracy. Also we have compared with the area estimation. So here you can see 20% difference is there with the actual area, but because that may be because of advanced SWIFT satellite, that is coarse resolution is there. But you see same time LIS-3 satellite, same time it is done by the SAC. If you have LIS-3 image with the single date, it is comparable with the observed estimate of the Bureau of Economic Survey, almost comparable. So single date image in the crop region like Haryana or Punjab, where monocrop region is there, only you will find mainly wheat in the Rabi season, and some pockets identified major dominated area in the like mustard or sugarcane. Rest is or majority you will find wheat crop. So one also example I can show you, tell you that with the LIS-3, we have done here for the different variety level, like you can see different variety, even coarse variety and fine variety. If you have got good ground truth, it is all depends on the how best you plan your ground truth observation collection, satellite image acquisition, your right time of satellite acquisition. That can even single date can facilitate you to classify even up to certain, like this 2 variety which has got almost different kind of canopy architecture, leaf means greenness of the leaves, and also you will find a difference with respect to the harvesting maturity time. So because of difference in the maturity time, greenness, and also the its canopy characteristic, we could able to classify these 2 variety also of the rice, very coarse grain and very fine variety in our Saharan. So it is not that you cannot do varietal classification, but all it is area specific is there if you have very good ground truth. But operationally at the variety level, it is still quite challenging. It is in the research stage, but surely you can do crop level, like different crop types, meso crops. Certainly you can have good classification and make good acreage estimation with the reasonably good accuracy. Also one of my colleague will take also lecture on the microwave, but microwave nowadays, for rice, yes, we were talking about rice. So rice, because that is a mainly crop which is practiced in the rainy season. So during Kharif season, there is a biggest problem of cloud. So whenever there is a cloud, you won't get the optical satellite data like LIS3, LIS4. They all are optical satellite data. So these satellite data are quite affected by clouds. So cloud contaminated data you cannot process for the any kind of classification. So to overcome this problem, we need to have a microwave radar satellite data, synthetic aperture radar, SAR data, because this radar remote sensing that allows you to acquire information in any kind of weather. So these are all weather independent satellite. They have ability to penetrate through the clouds and acquire information. So rice monitoring or rice crop acreage estimation in India mainly done with the radar remote sensing, whether radar set, reset, these are the radar satellite data. So they acquire backscatter information. Backscatter depends on the volume backscatter as well as specular backscatter, like transplanting stage. When there is a transplanting, because of water background is there is a more specular reflectance, and then once plant growth, biomass increase, then there will be a volume scattering. So because of different kind of scattering in the rice, it is very easy to discriminate rice crop from others. But same thing we cannot say. Same thing is true for other crops like high biomass sugarcane, pearl millet, this sorghum. Many crops are there. So we cannot achieve the same degree of accuracy with the radar set or microwave data what you can get with the rice, because rice has got different kind of transplanting and agronomic practice which facilitate or which can helps to discriminate with the SAR data. So another approach, as I said, that is if you have interest like whole in the state of Madhya Pradesh, if you want to get acreage estimation of wheat crop for whole Madhya Pradesh, then there is of course there is a MP cost is there, center is there, but even though if anyone want to have acreage estimation of whole state, then you need to have a different kind of approach. It is not like that you can acquire image for whole district and then classify. It is not cumbersome, time consuming, and not cost effective. You have to apply certain stratified sampling approach. The stratification can be based on the agroecological zone, previous year satellite imagery, person or historical crop proportion of the wheat in your area. So first, based on the crop proportion of wheat across different district as well as agroecological zone or person previous satellite imagery, you stratify into a different zone, stratum. After doing stratification, you do sampling plan. Sampling plan means you have to generate grid size of 5 by 5 kilometer or 7.5 by 7.5 kilometer grid overlay over the whole Madhya Pradesh state. Then choose only the 10% of this sample segment, 5 by 5 kilometer sample segment grid. You choose only 10% of those grid and acquire satellite data for only those selected 10% sample grid across whole Madhya Pradesh, randomly selected. Then only those sample segment you classify and get the accuracy by extrapolating with the stratified stratum proportion of the wheat crop area. That is called only random stratified sampling approach. So we'll say into detail. So this is one approach for the Punjab, where 4 zone is there, 5 zone is there, agroecological zones are there. For every zone, there are district boundaries overlaid also. So one district you are here, I am seeing either 4 or 5 sample segment. The square box are there. In one district, 4 or 5 sample segment are there. So this sample segment only satellite image is acquired, and then satellite images were first classified as a wheat 1, wheat 2, wheat 3. because it depends. When you go to field, you'll find certain wheat crop fields are in the flag leaf stage, certain are in the tillering stage, certain are just okay immersed, or maybe okay in the anthesis stage. So in such case, though all three stages has got different kind of spectral signature. If you take them as a single crop, then you may not get the good accuracy. So all these different stages of crop, first you have to tag in the image or train the algorithm with the different name like wheat 1, wheat 2, wheat 3. Classify them as wheat 1, wheat 2, wheat 3. Then finally, you aggregate into a final classification as a wheat. So training ground truth level, you cannot mix all those different stages of crop. You collect as a so this particularly here you are seeing that also this all finally it is aggregated as a wheat, sugarcane, forest, and water. Different classes are there. Then also this sample segment, once we multiply with the stratified proportion for different stratum in the particular district, you can get aggregate to the district level acreage estimation. So how this particularly you can see here how it works. Acreage estimation. You see this is one Haryana, where first we are seeing first here Haryana 5 by 5 kilometer grid is overlaid. Then those selected out of this whole grid, only 10% of this grid are selected for the different district. Then this is you can see one grid. Then this is a one grid is there. So particular grid, you carry out the ground truth or acquire the satellite image only which represent the particular sample grid. Go to the field, acquire the ground truth like here, you have classified, identify with 1. Then here, another grid you are seeing, with 2 kind of thing. Then here, somewhere, with 3 also there. Then here, this is a mustard. This is a mustard. This is maybe groundnut. So different crops you can collect. So this is earlier. There was no GPS, so we could not able to exactly identify the location. But nowadays you can have GPS. You can note down the latitude, longitude, and other information. Then identify those latitude location of the ground truth site in the satellite imagery with the computer IDAS or commercial software. Any commercial software or free open source software like Idrisi or QGIS, all can support nowadays image processing. So this is all identification of the ground truth site in the satellite imagery. After this, you can do spectral separability generation. Different classes are there. How they are separable from one to another. If any class you are finding overlapping, then you define your ground truth site with the exact location. Then you see if separability is there or not based on the transport divergence or Bhattacharya distance. Once you get this certain crop are not separable, you can mix or you can do more refinement of the classes. Once they're done, then you can apply some MXL algorithm to classify them into a different grids are classified. Sample segment are classified here. All sample segment are classified. That square box. Then after this classification in particular district, maybe 4 or 5 sample segment is there. You take out its acreage of particular crop, multiply with the stratified proportion, and aggregate that crop with the district level crop acreage estimation. So here in the crop acreage and production estimation project, mainly for the dominant district. Here you are seeing for mainly dominant wheat like Haryana, Punjab, Madhya Pradesh, Rajasthan, Uttar Pradesh. Dominant district, phase 1 and phase 2. Different crop production estimate is estimated and also methodology is being developed for those all states. Like rice also Orissa, Tamil Nadu and other phase 2 also. Now it is in Fasal. We are monitoring all this crop and giving every year production acreage and production estimate for the rice, wheat, so and all other crops. Like groundnut in Gujarat only, phase 1, and then it is extended to the Andhra Pradesh, Karnataka and Maharashtra and Tamil Nadu in phase 2. Now we also continuing this all groundnut, cotton. Now we have gone to jute, sugarcane, some other crops, bajra, some other research stages are there. But jute, sugarcane, cotton, and then onion, potato, all is nowadays covered under either horticulture crop mission or the Fasal project. Suppose that is all about state level, all these things. Suppose you want to have some nationwide crop acreage estimation. So you cannot use that least 3 or least 4 kind of satellite data. Then you need to use some force resolution satellite data like advanced WIFs or WIFs or OCM. You apply certain multi-data approach, then you can classify. So here this is one example what I am showing, because it is not only the particular approach what you are using. It is based on the knowledge of the agronomy of the crops. If you have good knowledge about when a crop is sown, when it reaches to the peak growth stage, when it gets harvested in a particular region. So depending upon the knowledge about the phenology, or you can say crop calendar of the different crops in a particular region, you shall acquire satellite image. And this knowledge also helps you to see better application of the multi-state satellite data. So here one approach what I am showing that with Gujarat or Maharashtra, where mustard you will find wheat in the Rabi season, and also in some whole like this mustard and this. So here mainly you see that this is a NDVI profile curve is there with the multi-date data 1, 2, 3, 4, 5, 6 dates are there in a season, Rabi season. So here you are seeing wheat crop is growing, NDVI is increasing and reach to the peak growth stage, particularly in the mid of February. Then it is declining. It is further little bit decline and attain the senescence stage and get harvested by the March end. But mustard, here you see the mustard. What happened? It is sown after the end of October, reach to the peak growth stage, particularly December end or December mid or end. It is to the peak growth stage. So NDVI will be very high when crop is in the vegetative growth stage mustard. Then it turns to flowering stage. So when it turns to flowering, it becomes all yellow. When it becomes yellow, so when it turns to flowering, it becomes yellow. And yellow flower doesn't have chlorophyll concentration. When it doesn't have chlorophyll concentration, what will happen? Green area index goes down. As a result, NDVI goes down. So you will find one dip in the first week of January. Then again, flowering is over. It turns into a pods. So pods are again green. So it adds to the chlorophyll concentration more. It adds to more chlorophyll concentration. So it leads to the further increase in the green area index. So you will find another peak, particularly in the end of January. Then after it will start maturing. Because of maturity, yellowing of leaves will start. So again chlorophyll concentration will reduce and crop senescence will take place. So finally this NDVI goes down. So here what I want to say, particularly for mustard, you will find 2 green peak, NDI peak. But in case of wheat, you are finding only 1 peak. So for mustard, suppose you are interested for the acreage estimation of mustard, then you shall acquire satellite image, particularly during the stage when it turns to flowering. So whenever, in whichever region, when it becomes flowering, when it reaches to the flowering stage, you acquire satellite image, particularly if you are interested for mustard crop acreage. If you are interested for the wheat crop acreage, you shall acquire in the mid of February or last week of February. Then only you can get the best accuracy assessment of the this mustard and wheat crop. So satellite data acquisition is quite good, quite important with respect to the accuracy, attainment of the accuracy of classification or discrimination. So it is not only the kind of satellite data, partial resolution matters. You need to have a good multi-date resolution satellite data that definitely improve, like what I am showing. Based on understanding of the phenology and spectral growth profile approach, you can use 3 or 4 date satellite data, NDI, and classify based on the decision tree classifier, it's knowledge-based classifier. So here all you require to use your agronomic knowledge for particular region. Then we can better classify different kind of crops. So here I can summarize this, okay, different with respect to different kind of resolution like that. Okay, national level, if your interest is there, you can do 180 meter resolution or WIPS or OCM. You can classify rice and wheat for whole India. If like advanced WIPS, which has got 60 meter resolution, you can do this kind of this kind of satellite data for classification of rice and other crops in Andhra Pradesh state level, like okay, wheat, what I have shown. You can do rice, wheat, sugarcane, and mustard, particularly in the Haryana. Similarly, in case of Andhra Pradesh also, only whole state level rice or other crops you will get. When you are having district level classification, then you need to classify more crops like rice, cotton, and other crops. Then you use least 3 kind of image resolution, least 3, Sentinel, least 4, Landsat, Ester. This kind of satellite data is good for the rice and cotton or district level mapping. Suppose you are having higher resolution satellite data, or your interest is to have village level crop inventory or block level mapping of the crop, different kind of crops, then you can use least 4 or better resolution like least 4 or Sentinel, which has got 10 meter resolution. So Sentinel or least 4 that can support mandal level, block level crop type discrimination. You can identify more number of crops if you are having higher resolution. And like okay, here you can do maize, chili, all those what I have shown for one. Beyond that, okay, if you are having a higher resolution, you can CAAST, or even like a spot imaging, peak bird, all those high resolution satellite data having less than 1 meter spatial resolution, multispectral. You can do mapping of different kind of crop at the field level. So village level, village level, all fields, you can map what are the different kind of crops grown. And that kind of application support, particularly for the crop insurance studies or precision agriculture or you can crop management, which all based on the at village level, field level mapping. So smallholder field level mapping, all you can do with the high resolution partial satellite data, both multispectral and the multi-date. So village level, okay, same, okay, you can do with the boundary level overlaying approach. But nowadays, okay, with the technology development, beyond MXL classifier, now object-based identification is also possible. Where okay, not only pixel-based approach. Nowadays, people are using advanced approaches like machine learning technique or object-based approaches, where satellite image, depending upon the shape, color, of the peak segments, satellite image, shape and color, shape of the different feature, like on the ground, if orchard are there, they have rectangle or some kind of space, shape, if certain crop has got certain kind of shape and color, means spectral signature. Based on that, satellite image is converted into objects, and those objects are classified. So it can improve the accuracy. So if you have high resolution data, then object-based approach is very much useful. So like what we have done for the potato crop, like mainly horticultural crop assessment, which are very small patches are there. So you require high resolution satellite data. And when high resolution satellite data you are using, high resolution multispectral satellite data, you can do, so if you can do object-based approach, then you can achieve good accuracy. So you can give different kind of weight to the color. Color means a spectral signature, and shape means the kind of object, like orchard is there, all those things. You give different kind of weight. Then okay, based on using this kind of approach, you can classify. So here you see first, okay, satellite image for this is one village is there, village set Narhara village in the Meerut district, where we have first classified or first generated the image object. So these all image object based on spectral signature and shape, they are generated. Then 2 or 3 level image object are generated. After that, they are classified into a different crops. So this is one MXL pixel level classification, MXL algorithm, where one village, this Narhara village, satellite images of list 3 and PAN. Then to me sharpen at 6-meter resolution, PAN sharpen list 3 image is classified into a potato, wheat, potato, sugarcane, fallow, and other built-up land. So further we have done also with the image segmentation. Okay, here you can see that this is a one MXL classifier, and then we have done also image segmentation. So to apply with the object-based approach and understand the accuracy. So you can see here MXL approach potato classification accuracy is only 77%. The moment you convert into object-based analysis or object-based image segmentation approach, accuracy improve for the potato crop discrimination. So that is the beauty of the advanced classifier or advanced image processing techniques. So further, all those is useful for the, suppose you are doing for hailstorm damage assessment or crop pest disease assessment or some crop insurance related studies. You need to have a field level crop mapping. So unless you don't analyze at field level how NDVI change or how crop vigor is changed, then only you can best identify or claim settlement, or you can say crop loss or damage, crop damage assessment you can do for the particular farmer. So what we have demonstrated a little bit for the field level scale, how much damage is there, severely damaged, moderately affected due to the hailstorm in the potato. Similarly, another exercise what we have done for the mill level, like okay, different sugar mill are there. All sugar mill, they are providing the sugarcane price is variable across different kind of mill. And then they have crushable sugarcane. How much crushable sugarcane has capacity? I mean, particular mill, how much capacity they can have? That depends on the amount of millable sugarcane is coming to the particular sugar mill. So we could able to do with a certain kind of methodology discriminate sugarcane crop. Like here you can see pixel based and image segmentation based. Both we have tried with the list 4 and list 3 data. Then you see here planted cane and ratoon cane. Planted means the which is sugarcane set is planted and it is grown for whole year. Next year, okay, it is cut from the bottom by leaving okay somewhere okay 1 or 1.5 feet stem to regrow next year. That is called ratoon sugarcane. So we could able to achieve reasonable accuracy of ratoon and this planted cane sugarcane crop discrimination, but accuracy is more when we applied this image segmentation based approach. Then also okay, multi-date, okay, if you are having a 3 or 4 date of satellite data like list 4 or list 3, you can further even improve the accuracy of sugarcane crop classification. So we could able to do this, okay, for sugarcane plant in the one of the another district like Bagpat in the Meerut district. So there Bagpat sugarcane mill, Sarkari chini mill. So there we have done, okay, for MXL as well as this classification. Now you can see decision tree classifier. We are getting the list with the observed whole sugar mill, total sugarcane area and estimated area. Difference is only hardly 0.56, less than 1% difference is we could able to see. But in case of list 4 satellite image, even though with the image segmentation, image difference is 7%. So it is what I want to convey here is that if you have single date image, you cannot achieve a very high accuracy, because you can achieve good accuracy with the multi-date satellite data. Hello? Hello? So here you can see for different fields also has been mapped for with the object based classification and the list tree based classification, and also compared with the field survey, GPS based survey of the sugarcane and ratoon crop. Also, it is could be possible to certain level to map the different kind of agroforestry system like haze cropping, agro-horticulture where mango and wheat crop is mixed, growing, and also haze crop like poplar surrounding the wheat crop. So this kind of cropping, if you have high resolution satellite data, you apply image segmentation approach, you can map to certain extent this kind of crops. We could able to do this with the list 4 satellite data and pan-sharpen list 4 satellite data. So here you can see all this, you are seeing that, okay, all this, that boundary you can see this field boundary. So you can map this field boundary. These are the haze, poplar haze. All green is that poplar haze. Inside is a crop. So crop and crop haze as well as agro-horticulture, we could able to map with the both world view satellite data, that is a very high resolution satellite data. Then is a merge cartosat and list 4 satellite data. We could able to see the haze of poplar and a different kind of mango orchard or field crop within the crop field. So summarizing, we have got, okay, based on the experience and different technological tools being developed over the last 3 decades, a new center, mainly institution for the operational agriculture crop monitoring is being established by the ISRO, that is within the Ministry of Agriculture and Farmer Welfare, which is called Mahalanobis National Crop Forecast Center. And this center is now given a mandate of operational agriculture crop monitoring of all 10 to 15 crops with the technological input from the ISRO. So today, all state level assessment done with the multi-date advanced data. District level acreage estimation is done with the Sentinel, list 3, reset and data, and acreage estimation is given in the bulletin. So there are different kinds of crops, potato, mustard, rice, wheat, all jute, almost 12 to 15 crops are being operationally monitored acreage as well as production estimate under the Fasal program. Fasal is nothing but forecasting agriculture output using land, agrometeorology, satellite space, agrometeorology and land observation. That is called Fasal. Under this Fasal program, the software is also developed like Fasal Soft, which can enables you to classify different kind of crops, mustard, wheat, or different kind of crops with the image processing tools and techniques. Then also ground truth application, ground truth mobile application is developed also, which can support taking ground truth, entering different kind of canopy attributes while you are going to the field. You can download this kind of mobile application from NRSC one website for ground truth, taking ground truth. What kind of observation you can take? So likewise, this okay for sugarcane ground truth mapping. We have developed okay sugarcane ground truth mapping mobile application which you can download from Bhuvan and use for your this. Likewise, okay, for wheat crop, other crops also available. Or what are the different canopy attribute you have to collect, its location, you can enter, and directly these all images is uploaded on the Bhuvan server, and that ground truth you can use for the classification. So last, we can see this is all about technology, but still there are certain limitations because one biggest problem in India is the small size. Haryana, Punjab, it's okay. We have okay optimum more than 1 hectare field are there. But Madhya Pradesh, Gujarat, Maharashtra, where I see there is a lot more variability in the crops. Particularly 1 hectare field, you will find wheat, mustard, even some fodder crops, some vegetable crops, even some gas crop. So in the same field. So hardly field size is 0.2 hectare. So it is very difficult to resolve with the existing satellite sensor to map all different kind of crops. That is why we have developed an approach which can enables you to classify only the crops which are grown in the major dominated district. So not only where okay you are having a very less crop acreage in particular district for particular wheat crop, you cannot classify. That is the biggest limitation. Another large diversity of crops sold means many number of crops are there in different districts. Third is a large field to field diversity in sowing culture. This means variation in the sowing time. If you see Madhya Pradesh, Gujarat, there okay we sow crops, this wheat crop in the particularly first week of May, November. But in our Dehradun, it is okay, even we sow wheat crop in the January mid. Haryana, it is sowing in first week of this, okay, November. So there is November first week to almost January, means more than 2 months. Sowing window variation is there in India. So this affect the acquisition of satellite data as well as classification. Then other factor affect also is the intercropping and mixed cropping practice in India, which you cannot resolve with the existing satellite data. High cloud coverage, particularly we are in monsoon Asia. So cloud coverage is high, particularly July, August, September. You won't get the satellite image from the optical satellite data. So there are certain crops we cannot classify. Then also the crop proportion, environmental factor, time of satellite acquisition, all affect the classification accuracy. So finally, multispectral data has got ability to classify different kind of crops and condition assessment. But we require to have a long way to go for acquisition of correct kind of satellite data, large operational application and larger scale. We could do all those okay crop insurance or field level, village level mapping if we have got okay 5 to 10 day 10 meter resolution every 10 day, or all this can be achieved with the constellation of the satellite. If you have okay 4 resource set kind of satellite operated in the same orbit, say 3 or 4 constellation of the satellite like okay resource set, and we could manage all our agriculture application. This is all about this okay different challenges and application. Now I am very happy to answer few of the question put by you. Please go ahead with the question. Tell me. Question, please.
Sir, there are questions in chat box. If you can
Chat box. Okay.
Yes.
I'll see. Question is there.
Sir, it starts from what should be the minimum field area for LST and indices calculation for crop monitoring.
Minimum field area for
LST and indices calculation for crop monitoring.
LST calculation. Oh, LST and indices. You are telling LST, land surface temperature.
Anjali, can you clarify?
What is our minimum field area for computing LST? Okay, LST, okay, that is okay. Field area is because here, if you have Landsat image, then land surface temperature you can acquire from the Landsat data, and you can do this okay for 1 hectare field, some LST calculation. I'm not understanding what question is there. Hello, please.
Sir, there is another question. Does hyperspectral images will do better in identifying different crops of same family like maize, bajra?
Yeah, exactly. You are very correct. Because hyperspectral image, if it is acquired, because hyperspectral has got very good spectral resolution, so it can support even up to varietal discrimination, and different confusive crops can be discriminated. Yeah, so phenological growth stage can better estimated when different variety can be nicely discriminated. And even you can confusive crops like okay barley and wheat, or some sugarcane variety like, or cotton, different desi cotton, hybrid cotton, all you can discriminate with the more accuracy. But problem with the hyperspectral resolution is that you won't get the multi-date data. So multi-date is very much important, frequent repetitive comparative to the spectral resolution. Suppose you are doing in the certain area where you require multi-date data. So you won't get the hyperspectral remote sensing data cannot be acquired with the very high frequent repetitivity. So as on today, if you have like sentinel data, which you can acquire every 10 days, that can support even most of the crop. You can nicely discriminate. You need not to have a hyperspectral data. Hyperspectral is very good for the varietal discrimination, phenological crop stage discrimination, or the crop trace assessment. Any more question, please? Yeah, for different crop growth stage based on the height. With different kind of crop growth stage, you can discriminate based on the radar remote sensing data also, that can give you information about the canopy height. Okay, but hyperspectral, mainly hyperspectral, that can discriminate different phenological stages also. More question, please. Hello.
All the participants, if there are any questions, you can ask. You can unmute yourself.
You can ask. You are by audio also. You can ask. Dr. Rajendra.
Sir,
Please, you can ask. You can ask if you have any query.
Sir, Nema sir is not present here. Actually, he's attending the second meeting that
Okay.
parallelly going on.
Okay, whoever is there, okay, if you have a question, you can ask. Yes, okay, Ankit Yadav, which is the technique develop displaying? Where it is this? Chart. Okay, let me see. So, which technique is more appropriate for the hyperspectral data to crop classification? So, for hyperspectral data, there is a spectral angle mapper and the spectral mixing technique. So it depends on the knowledge what we have. But in my opinion, spectral unmixing, that can give you a better discrimination of the different kind of crop. Any more question? Other than hyperspectral, because here, okay, all of you should know, it is a more important is the phenological knowledge. If you have knowledge about the phenological growth stage, crop calendar, Then even with the multispectral data like Sentinel or Landsat, nowadays available publicly free 16 days every Sentinel image. Sentinel 16 days Landsat OLI, and Sentinel data is available every weekly. So with the creation of the multispectral, multi-temporal profile, you could able to discriminate most majority of crop. So hyperspectral as of today, hyperspectral is good for varietal discrimination, phenological stress discrimination, crop stress assessment, all those things. But they don't have, it doesn't have the multi-date data. So single date hyperspectral image cannot classify all crops, even though it has got many number of bands. That message you should take with you. Any more question, please? Hello? Okay, so thank you. Thank you, everybody.
Sir, there is one more question here.
Okay.
That is from Gotham. That is, does disease and pest incidence can be identified for small patches of land within the resolution limits?
Okay, disease and pest, particularly for disease stress, as I said, pest disease, nutrient stress, water stress, or heat stress, all give different same kind of signature in the thermal remote sensing with thermal image. Temperature will increase because of this all different kind of stress. So you can not correctly discriminate whether this temperature increase is because of which kind of stress. So thermal anomaly you cannot detect with the different kind of stress. So for this kind of different kind of stress, if you have acquired this hyperspectral image, then you can better identify the causes of different kind of stress. So pest and stress, disease stress means disease stress, that you can better identify whether it is because of pest or disease due to through hyperspectral, then only you can monitor. So what I want to submit is that different kind of stresses, pest disease or water stress or nutrient or salinity or heat, or you can discriminate or you can ascertain causes of stress through hyperspectral remote sensing only. So that is why abiotic and biotic stress assessment can be done with the hyperspectral remote sensing only. You cannot do with the any other kind of image. You can generate with the Sentinel or Landsat. That is a crop stress. What is the degree of crop stress you can ascertain, but what is the causes of crop stress, then only you need a hyperspectral remote sensing. Any more? Does hyperspectral image will do better in identifying different crops of same family like maize, bajra? Okay, surely maize, bajra, all those things can be improved with the hyperspectral data. Because even we have tried in the Rajasthan and Uttar Pradesh, even in Maharashtra, maize, bajra, and sorghum cannot be discriminated with the even radar set data with the good accuracy. But that can be possible if you can get the correct and quality image from hyperspectral. Because again, the problem with the hyperspectral is the cloud. Up to September, you won't get hyperspectral image because how cloud is there up to even September. After September, many crops get harvested, so you cannot classify. That is the biggest problem even with the hyperspectral data, because cloud will be there anywhere, and it affects the whether it is hyperspectral or optical, Sentinel or Landsat. You need the macro remote sensing data. Any more question?
I think, sir, there is a last question from Gotham, that there is any correlation study was carried out between leaf color chart and spectral reflectance of satellite image.
Yeah. There are many with this leaf color, like mainly leaf color spade, like chlorophyll concentration spade, leaf color chart or soil color. Soil color means chart that is with the different hyperspectral data. This kind of studies are being done in abroad, but now we are initiating with the soil color. Now initiating some project with soil color chart and relationship with the hyperspectral data.
Okay, sir. Thank you very much, sir, for providing us this valuable and informative lecture.
Okay.
We all the participants of this training benefited from this session.
Okay, tomorrow we'll discuss about this, okay, abiotic crop stage assessment in more detail with the hyperspectral and thermal remote sensing. Okay,
Okay, sir.
Thank you. Thank you.
Okay, thank you very much, sir.
Yeah.
Thank you to all the participants. We are closing the session now.